All right, welcome. Today, we're going to dive into Azure's SQL database options, and we're really going to focus on how they tackle massive scale.
So here's what we've got on tap. First, we'll tackle the whole challenge of scaling beyond the limits. Then, we're going to peek inside the Hyperscale architecture to see how it works. After that, we'll look at its supercharged approach to disaster recovery. And finally, we'll zoom out, check out some other deployment options, and help you figure out which vCore tier is the right fit for you. Okay, let's jump right in. The first big hurdle we need to talk about is one that's, well, it's easy to describe but incredibly hard to solve. And that is, what do you do with just a truly massive amount of data? And listen, this isn't some academic question. It is a very real problem for so many companies out there. You know, the ones whose data has just exploded past what their old database systems can handle. So what's the answer here?
Yeah, we're talking about a colossal amount of data. And get this, Microsoft says that 100 terabytes isn't even a hard ceiling. It's just what they've tested, and they're pretty confident it can go way beyond that.
And that solution is called Azure SQL Database Hyperscale. Now, this isn't just a bigger, better version of an old database. It is a completely new architecture, reimagined from the ground up specifically for the cloud. It's designed to use the cloud's strengths to just blow past those old-school limitations.
Okay, this right here is the absolute core concept. In a traditional database, compute and storage are basically tied together at the hip. If you need more storage, you might have to take everything down. It's slow, it's disruptive. Hyperscale? It just cuts that cord. It completely decouples them. So your storage can just grow and grow as needed, almost invisibly, while you can scale your compute power up or down whenever you want. That separation, that's the magic trick.
So how in the world does Hyperscale actually do this, How does it achieve this incredible independent scaling? Well, let's pop the hood and take a look.
The whole system is built on these four key pieces working in harmony. You've got your compute nodes, your page servers, a log service, and then your remote storage. Let's break down what each one actually does. All right, first up are the compute nodes. Think of these as the brains of the operation. This is where the actual SQL Server engine is running. You always have one primary node that's handling all your reads and writes. But here's the cool part. You can spin up multiple read-only secondary nodes. This is awesome for scaling out those heavy-duty read workloads like reporting or analytics without slowing down your main application at all. Okay, next up are the page servers. And honestly, this is the secret sauce for how the storage scales. Instead of having one gigantic monolithic storage system, your database gets chopped up into these 1 terabyte chunks, and each chunk gets its own dedicated page server. So what happens when you need more storage? Simple. The system just adds another page server to the mix. It's incredibly elegant.
And wrapping up the architecture is the log service. Its job is to grab transactions from the compute node and make sure all those page servers are kept up to date. And because storage in the cloud is, relatively cheap and abundant, this log service has practically infinite space. This is a huge deal because it means you never have to worry about the transaction log filling up, a classic nightmare for anyone who's managed an on-prem database.
Now, all this cool architecture isn't just for performance and scale. It completely changes the game for something that is, let's be honest, usually super stressful: disaster recovery.
No, really, take a second and think about that. A 50 terabyte database. If you're coming from a traditional on-prem world, you know that restoring something that big, well, you're not measuring that in minutes. You're measuring it in hours, or more likely days. And you're probably crossing every finger and toe you have, hoping it works.
With Hyperscale using its accelerated disaster recovery, Microsoft actually demoed a 50 terabyte restore that took just 8 minutes. 8! And what's wild is that the restore time is basically constant. It doesn't matter if it's 1 terabyte or 100 terabytes, it's still just a matter of minutes. So how is that even possible? Well, it all goes back to those page servers. The restore is massively parallelized. Instead of one big machine struggling to restore 50 terabytes of data, the system just spins up 50 page servers. Each one grabs its little 1 terabyte slice from snapshots and remote storage and restores it at the same time. It's an absolutely beautiful example of a scale-out architecture doing what it does best. Okay, so it's pretty clear that Hyperscale is an absolute monster when it comes to huge databases. But what if that's not your problem? What if your needs are a bit different? Well, you're in luck because it's not the only option in the Azure SQL family. So that's the big question, right? When would you actually choose something else? Well, it really boils down to your specific situation, especially if you're looking at migrating from an on-premise setup or if you're trying to manage a whole bunch of smaller databases.
So let's break down two of the big alternatives here. First, you have Managed Instance. Think of this as the easy button for lift and shift migrations. It's designed for maximum compatibility with your on-prem SQL Server, so you can move your applications to the cloud with minimal changes. Then you have Elastic Pools. This is for a totally different scenario. Imagine you have a bunch of databases, and they all have spiky, unpredictable usage. Instead of paying for peak resources for every single one, you just put them all in a pool where they can share the resources. It's a huge money saver.
All right, we're on the home stretch. Let's talk about performance and, of course, cost. So once you've figured out your deployment model like Hyperscale or Managed Instance, you still have to pick a performance tier. And this is all handled through what's called the vCore model.
So your choice here really maps directly to your workload. You've got general purpose, which is kind of your all-rounder. It's the balanced, budget-friendly choice for most standard business apps. Then you step up to business critical. This is for your heavy hitters, your OLTP apps that need super high transaction rates and crazy low latency. It uses blazing fast local SSDs to deliver top-tier performance. And then, of course, there's the hyperscale tier we've been talking about, which is in a class of its own for those massive databases that blow past that 4 terabyte mark.
And there's one more really important choice to make, especially within the general purpose tier: how you want your compute to run. You can go with provisioned, which means your resources are always on, always ready. It gives you that consistent, predictable performance you need for a production workload. But then there's serverless, which is, honestly, it's a game changer for dev test environments or apps with really sporadic usage. It can automatically pause the database when nobody's using it and wake it back up instantly. The bottom line? You only pay for the compute you are actually using, which can save you a ton of money.
So as you can see, it's not about one size fits all. There really is an Azure SQL architecture for just about every need you can imagine. The whole key is to really understand your workload. Is it about massive scale? Is it about easy migration? Is it about cost efficiency? And then match it to the right option. When you find that perfect balance, you've got a seriously powerful foundation for your next big idea.
Hey, if you found this explainer useful, do me a favor and hit that like button. Even better, share it with someone you think might find it interesting. And of course, subscribe for more deep dives just like this one. Thanks so much for tuning in.